Welcome back to Advent of Code. We're on day 16 now. So yesterday, day 15, was really hard. The challenge was the elves and the goblins were moving on a 2D grid and fighting. And it was hard for me to read the problem and get all the edge cases right. It was just a very hard problem. I had a few mistakes. I didn't realize that if an elf dies during a round, it can't fight in that round. And then I had one typo where I was filtering a list and not assigning the result, but just working on the original list. My first version, because I was working with tuples for the position, I could never use a set or a map because those tuples in JavaScript are never equal, even if they have the same x and y value. So the first version was very slow, and it did run on the complete input, but it would take some time. So I had to change everything to add my own hash map to it. So I was just hashing the positions by taking one coordinate times 100 plus the other one. And that made it very fast, but it was an extra step. Debugging the problem was hard at the end because it was passing in all the test cases, just not on the real input. But eventually I got it. I didn't stream all of it, I only streamed the beginning. So let's hope that day 16 is a little easier. As you see the elves defend their hot chocolate successfully, you go back to falling through time. This is going to become a problem. If you're ever going to return to your own time, you need to understand how this device on your wrist works. You have a little while before you reach your next destination, and with a bit of trial and error, you manage to pull up a programming manual on the device's tiny screen. According to the manual, the device has four registers, numbered 0 through 3, that can be manipulated by instructions containing one of 16 opcodes. The registers start with the value 0. So we have registers 0 to 3, and we have 16 opcodes. Ooh, are we building a compiler today? Every instruction consists of 4 values that can be manipulated by instructions containing one of 16 opcodes. Every instruction consists of 4 values. Oh, okay. So an instruction has an opcode, A, B, and C. Those are inputs and outputs in that order. The opcode specifies the behavior of the instruction and how the inputs are interpreted. The output C is always treated as a register. In the opcode descriptions below, if something says value A, it means to take the number given as A literally. This is also called an immediate value. If something says a register A, it means to use the number given as A to read from or write to the register which has that number. So if the opcode add I adds register A and value B, storing the result in register C, when the instruction add I 073 is encountered, it would add 7 to the value contained in register 0 and store the sum in register 3, never modifying 0, 1, or 2 in the process. Many opcodes are similar except for how they interpret their arguments. The opcodes fall into 7 general categories. Okay, add R, add register, stores into register C the result of adding register A and register B. Add I, add immediate, stores into register C the result of adding register A and value B. Okay, so the first one is the register, the second is the value multiplication. Mul R, mul I, which is stores into C the result of multiplying those two registers or multiplying the register and the value. So add I is the register plus the immediate, okay? Then there is bitwise AND, bitwise OR, Okay, ben I, Bori, Bitwise and, Bitwise or, assignment, set R, set register, copies the content of register A into C, set I stores value A into C, copies the content, okay. Greater than testing, oh, there's 3 of them. Greater than immediate register, sets register C to 1 if value A is greater than register B. Greater immediate register if immediate is greater than register, register immediate if register is greater than immediate, and R sets register C to 1 if register A is greater than register B. I see is set to 0. Oh, so greater than is true or false. Okay, inequality 1, 2, 3 again. C if A is equal to register B. If register A is equal to value B. Why would I need those? Couldn't I just turn them around? Okay. And register if the 2 registers are the same. Unfortunately, while the manual gives the name of each opcode, it doesn't seem to indicate the number. Oh yeah, because they are numbered by 16. However, you can monitor the CPU to see the contents of the registers before and after instructions are executed to try to work them out. Each opcode has a number from 0 through 15, but the manual doesn't say which is which. For example, suppose you capture the following example. But the manual doesn't say which is which. For example, suppose you capture the following example: 3211, 3221. And 9212 is the opcode or the instruction. This sample shows the effect on the instruction 9212 on the registers. Before the instruction is executed, register 0 is value 3, and so on. The instruction itself means that 9 was executed with A, B, and C. But only 3 of them behave in a way that could cause the result shown in the sample. Opcode 9 could be multiplication. Register 2, which has a value of 1 times it. Okay, so the only one changing here is the 3rd one. So this must be C. And we're going from 1 to 2. So we could have been multiplying 1 by 2. Which has value of 1 times register 1. Opcode 9. Wait, what are A, B? Oh, those are the values in A, B, and C. A and B, 2 times 1, yes. It could be add I, register 2, which has a value of 1 plus 1. Why does register 2 have a value of 1? Okay, let's see again. We have 4 registers, and there was something that we didn't know. We'll write to the register with that number. Register A to the register with that number. While the number gives the name of each opcode, it doesn't indicate the number. However, you can monitor contents of the registers before and after instructions, each opcode. Do we know that these here, so we have these 4 registers. How are we using them for the instructions? Do we know which registers are A, B, and C? Hold on. Two inputs and an output. Okay. Add store assignment. While it has the name, it doesn't give the number. Okay, so do we know that which one of these four registers are used for A and B? Okay, register 2 times register 1, or register 2 plus value 1, or value I number given for B is irrelevant. Alright. So we have the opcode is 3, and then we have A, B, C, right? Are those registers always in order A, B, C? It's some, alright. Through instructions has opcodes. The output C is always treated as a register. If something says value A, it means to take the number given as A literally. Okay, let's see here. So are those A, B, and we always store it in register 1, which would be this one here. So we take 2 and 1 as inputs. Register 0 has value 3, and so on. Okay. Was execute. Okay, yeah, so we're always using A, B, and C. No, this is A, B, and C. Okay, 9 could be multiplication of a register because we're taking register 2 multiplied by register 1. Yeah, okay, so I think those are in order. Okay, so now we know that 9 behaves like 3 opcodes. You collect many of these samples, the first section of your puzzle input. The manual also includes a small test program. Is there a brute force way of trying all the ops first? Yeah, I think so, because there's only 16, so we can do that. Okay, ignoring the opcode number, how many samples in your puzzle input behave like 3 or more opcodes? All right, so let's look at what this puzzle input looks like. Because they were saying that there's 2 parts to it. Oh yeah, so this is where it's changing. So we need to look for 2 blank lines. You know what, I will, oh gee. Thanks for joining that guy, JK. Have you solved this yet? All right, so here's the puzzle input. Now they were saying a test program, and I can ignore it for now. Well, that's great. Where are my unit tests for this one here? Did you solve any others of this month's Advent of Code? And if so, in what language? Okay, so I have these test codes. I have 16 opcodes. All right, here we go. So day 16. So we have this input, and we want to, what do we want to do? So we have 16 opcodes. And I think we kind of need to write them out. Let me just have a look at the question real quick. Ignoring the opcode numbers, how many samples in your puzzle input behave like 3 or more opcodes? Okay, so we want to go through every sample and see which opcode it matches. I guess I need to write out all the opcodes, right? So we have one for add, we have one for multiplication. That was kind of a long list. We have Bitwise, and we have Bitwise or always with a register first and then an immediate or register. Then we have assignment. Then we have greater than and equality. Greater than and equality, and I still don't understand why we need 3 equality testers, because sets register see if we are testing immediate and register, couldn't we just switch the order of the inputs? Hi there, how's it going? You told me your name yesterday and I already forgot how to say it. Sengimit? Well, thanks for joining again. Let's hope that today goes a little bit easier than yesterday. Yesterday was hard. Okay, so we have 1, 2, 3, 4, 5, 6, 7 is 14, and then 2 of them have 3. So that's how we get to our 16. And before we do that, I guess I want to pass the input for that line of inputs. So for every line, let's just make sure, yeah, those are empty lines. All right, hello. So for every line, we want to have one set of instructions. If line that matches before, then, okay, so we have registers before, that registers after, and we have let instruction. And I want to say the before is register 0, 1, 2, 3. Okay, so this is definitely an array, and this is an array, and the instructions are really opcode ABC. So I guess it's also an array. So let's do Oh, did I have? Oh, thank you. Yeah, it's match. Thanks. That would have been an annoying error figuring out why matches is not a function. I would be like, oh, is line not a string? And like wasted a ton of time. Thanks. I love it when people see those typos. Okay, so if we match before, then we want to take line that split. And of that, we want to take the second parameter. So that should be an array. And then we want to cut off the first letter, and we want to cut off the last letter. So when we splice that with 0, it should cut off the first one. Right? So let s equal this, console.log s, note, and we're on day 16, reference arrow I is not defined in line 37. And I don't get anything. Let's leave out the splice. I'm not using splice correctly. Nope, I'm not using split correctly. So it matches as console.log match. Oh, because I'm using the test input, which in this case we don't have. All right. So the match is, oh, there's more zeros in here. Okay, so we want let register 0, register 1, register 2, register 3. No, that is silly. So registers before, and the first input that we get is the word before, which we don't care about, and then we get 1, 2, 3, 4. So now we just need to clean those up a little bit. Why is registers before so weird? Oh, it's just a 0 because I need to spread those. No, why does this not work? So I'm splitting this. I'm splitting this. Oh, sorry. Line that's split. And I'm getting before 1, 2, 3, 4. Okay. And now I want to assign the last 4 ones to register. I thought I could do that. All right. Yeah, thank you, Finn. This is much nicer. I'm just going to copy and paste that. So line that match is all the numbers. I know they're always single digit. Yeah, I know they're single digit. I turn them into numbers, and now registers before is equal to that. How does that look? All right, thank you very much. And then if they match after, then this one is registers after. Okay, so I have before, I have after. That looks good. And then we need one more. If line not equals the empty line, then again we want to match them by numbers, and here the registers can be 2 letters, so I have 1 or 2, so not a star but at least 1, and that should be the instructions. No, it's 1 instruction, right? Yeah, this is 1 instruction. Console.log, show me that instruction. So I'm starting with 0022. And the instruction, oh, else if, is 9230. And just to make sure, console.log the registers after. Yeah, I was using the same for after. So I was making my editor terminal larger, which has the side effect that I can't see the chat anymore. Oh, I guess, oh, I don't have my phone on me. All right, so tomorrow I look at it from my phone, but I'll just be looking over every once in a while to see that. Okay. Phew, 30 minutes just for a little bit of matching. Okay, we matched all of them. They're all numbers, so that is good. So we match those, and we need to put them in a set, I guess. So for every line, we're doing that. And how do I work on these 3 now? Let examples is an empty list, and let example is also an empty list. Example that push before, example that push after, and example that push the instruction. So we're pushing all those in. And then here we want to examples that push example, and example is an empty one again. And I want to do this if examples.length is equal to 3, then I want to return. Now I want to console log examples. Let examples. Alrighty. So we're pushing the first one, so every row is an instruction. Makes sense. Let's take out these. And for now, let's just work with 3 instructions. So for every line of input, we have them in the instructions. I don't want to return, I want to break at this point. So now that we have them, for let instruction of let before instruction after is equal of examples. So for every one of them, I think I need to go through the list of opcodes and see if it is true. Let valid opcodes equal 0. Let opcodes is a list for let opcode of ops. Okay, how do I write this opcode? All right, so the example says 0, 0, 2, 2. I have 4 registers. Why did I have 4 registers? I need to go back to the example. Okay. Oh, hey Valence. So for somebody who wants to work at Google one day, what advice do you have to impress the recruiters there? What advice do I have? Know your data structures, know your algorithms, and practice these coding interviews a lot. Think about edge cases, think about testing. So actually these puzzles here are really good advice. I guess are you talking about a software engineering position or some other job type at Google? And I guess there's 2 things. So first, you in some sense have to impress the recruiter, because the recruiter, I want to say, is the first person who looks at your resume. Yeah, software engineer. So there's one step where you send in your resume and somebody has to say, okay, let's have a phone call with this woman or man. That's usually the recruiter. And after that, you really only have to impress your interviewers, which are other engineers. So I honestly have 0 idea what the recruiters are looking for in the resumes, but I'm sure there's a ton of information on the Google websites. I'm assuming, no, I really don't know because I don't work as a recruiter. But then for the engineer, you need to know, so once they do decide that they want to give you a call, you usually have a phone interview with an engineer, which is a small coding problem that you do in a Google Doc. And for that one, you need to know your data structures, your algorithms, runtime complexity, space complexity. Think about edge cases, unit testing, be able to listen to feedback or suggestions that you get during the interview in case you are stuck. You need to be able to communicate what you're coding. Yeah, so puzzles like these are good testing, and then there's a ton of websites that have shorter puzzles because you need to be able to do them in 45 minutes. Yep, that's my advice. Is that helpful, I hope? Okay, so back to this input. This sample shows the effect of the instruction 9 with the inputs 2, 1, outputting into 2. Does Google look for any language in particular, or is it good to go with what I know? I don't think we're looking for a particular language. If you're at Google, there's usually only a handful of languages that you will work with, but anybody who shows that they understand data structures and algorithms in the coding interview, we assume that they can pick up other languages as well. So I want to say most of the time you can do the coding interviews in whatever language you want. What language would that be for you, Valence? Okay, cool. I hope that's a little bit helpful. Oh yeah, JavaScript and Java is perfectly fine. I would suggest Java or JavaScript for the interviews. Unless C++ is the only thing you know, I would not do C++ in the interview because you just have to write so much more to have the same functionality. Oh, you don't have to work with Node. I mean, that's not part of the interview at all. Cool. Yeah, good luck if you decide to apply. It's a fun place to work at. Okay, you're welcome. Okay, so we have 4 registers, and an instruction works at most takes at most 2 of them and could put them into a third one, but never on all 4. Is that right now? And I have register 0, 1, 2, and 3. Okay, so for every opcode, I want to take so let opcode equal a function that takes A, B, and C. Let's just write out one of them. Let us do addition of immediate, which is addition of immediate, which is register plus value. So the opcode takes A, B, and C, and then it takes a before and after register. And now it takes, so A is the first value, so we want before of A plus the value B, and we are setting after of C to this, right? The addition opcode takes 2 inputs and an output, and it takes the before register, and then in the after register it's only changing the C value. And so now we want to return after. So for let opcode of opcodes, we want to call opcode of A, B, C, which is instruction of 1, instruction of 2, instruction of 3, and then we want the before and after. Let res equals opcode. Oh no, it doesn't put it into after. Silly. Silly, silly, silly. It puts it into after, it of course changes the state of the register that it had. So these registers should stay the same. Let's just look at this example again. Yes, they stay the same except for this one here. So because it's changing register with number 2, 0, 1, 2, 2 is the output here. Okay. Yeah, so it's changing before of C is equal to the register at position A plus the value B, and we're returning before let res. And now if for let valid is equal to true, for let register of results, no, for let I is equal to 0, I is less than result.length, I plus plus. If result of I is not equal to the after of I, then it is not a valid opcode. And we can break out of this comparison. So if A is equal to B and the valid opcodes is a list, let opcode of opcodes is a list of functions, valid opcodes. So if it was a valid one, then valid opcodes that push the opcode, do that for all of them. If valid opcodes that length is larger than 3, let count equals 0, then we're increasing the count. And then valid opcodes gets reset with the next instruction. Okay, so all that's missing here is writing out all these opcodes. So we take an example, which is those 3 things, and we look for the valid opcodes. So for every opcode in the list of opcodes, which we still have to write, we say the result is apply the opcode of instruction 1, 2, 3 to the before register. Let equal registers is a function that takes R1 and R2. And it says valid is true for let I in if R1.length is not equal to R2, that length console log wrong inputs register 1, register 2. We're going through the length of R1, and if R1 is not equal to R2, then we can, they're not equal. If we finish the loop, then they are equal. So let equal registers takes 2 registers. If they don't have the right length, then something went wrong. Then we're going through the thing. If one of them is not equal, okay, I like that. So here we can say if equal registers of result and after, then it was a valid opcode. Okay. So that doesn't look too bad to me. So count is 0, count plus plus, and at the end we want to print out count. Let's clean this all up a little bit. Here we have the list of opcodes. That's where I need to remember what they are. Let opcode equal to this. Let opcode at I, and then we want to do opcodes that push opcode add I. Yeah, this was register and value, which should be add I. I guess this is a lowercase I. So now this should give us which of those have the add I as a potential one. None of them. Okay, let's do it with why do I have so many counts? Count is 0. So this was all the parsing. And then count is 0. What was I doing here? This was because I wanted to stop this after 3 rounds. Okay, I'm very confused. I'm sorry. I confused myself. So I wanted to say valid opcodes that push. Oh, if I have 3 in there that are valid, then I'm counting up. Well, let's only count up those that have more than 1. I still don't have any. And when was I breaking? If example that length, let's do this for 30 examples. Okay, so I have 10 of them that could potentially be a plus. Seems to work for add I. All right, so I think what we need to do now is just add all of them. So if the count is bigger than 2, because we want at least, if the count is bigger or equal than 3, yeah, that's right, bigger or equal, and count goes for every opcode. If we found more than 3, then the count goes up. Let me just reread the problem one more time, just in case. Ignoring the opcode numbers, how many samples in your puzzle input behave like 3 or more opcodes? Yep. All right, let's implement all of them, I guess. Yay, we're writing a compiler. Okay, so we have opcode add I. So we need to have add R, I guess. Add R, add I, and really add R should come first. A, B, C, register plus register. So we want before of A and before of B. Okay. Let's do mul R, is that how it's called? Mul R and mul I. A, B, C. So we want multiply is R times R. And we want before A multiplied by B. And then we want mul I. So we want multiplication is the register plus the value. So let's just multiply by B. Okay, that's the two mul-i's. And I could do this less explicit, but I think I like that explicitness. Opcodes that push opcode mul-r and opcodes mul-I. And what's the next one? Multiplication bitwise r. So let banner, which takes bitwise AND of the two registers. So we want A and B. And now we want the bitwise with the value. So A and B. And now we want bitwise OR. And bitwise OR bor and bor-I. Bitwise OR bor and bori. Opcodes that push opcodes banner and ban-I, and bor and bor-I if opcodes that length not equal to 16 can't counting is hard, and return. Okay, so we have bitwise OR, so I think the next ones were the greater at, oh, assignment. So assignment was, copy and paste those again, set R and set I. Assign copies the content of register A into C. Copies register R into C, so C equals before of A. And then copies value A into C. Let's just quickly double check. Set I. So set I, set immediately stores value A into register C. Input B is ignored. Stores value A into C. Okay, and now we need the greater than testing. So this would be greater than immediate register. Sets register C to 1 if A is bigger than B. So we do greater than value A greater than register B. Okay, so before C is equal to A greater than before B, set register C to 1, otherwise to 0. Let's double check. Set register C to 1 if A is greater than register B. So if A is greater than register B, then to 1, otherwise to a 0. And then, so we have GTIR. Oh, I'm sorry, I didn't. No, I did switch back. Oh, I have a window in front of this. Duh. So we have GTRI, register immediate. GTRI if register A is greater than value B. So before of A is greater than B, then it's a 1, otherwise a 0. And the last one in that comparison was RR if the two register are greater than. Okay. No, we're so close, I think. Well, modulo any off by 1 errors that I made. So RR register A greater than register B. So if register A is greater than register B, okay, I got those. And now the last one is equality testing. So we want equir, equar and equar register A equal to register B, register A equal to value B, register A equal value A equal to B. So if those are equal, then it's 1. If those are equal, then it's 1. If those are equal, let's get rid of those. Opcodes that push, and we want to push opcode greater than IR, RI, RI, and RR. And we want to push equals, oh, that was silly. Equals IR equals RI and RR. Equals, okay. And was it greater or greater than equal? So greater than sets register if it is greater than, not greater than, not equal. Oh, hey, K-Steer. Yes, I have stuff on GitHub. What else did I said? I said things like info. Yeah, so what am I doing? What am I doing? Common question, but like a question of my life, I guess. But you're also welcome to just ask questions instead of writing them in the chat. Okay, I think we're pretty good now. We have all of them in here. Let's see if this still runs. Oh, counting is hard because I did not add all 16. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, I forgot to add the ones for setting. Op opcodes that push opcode set r and set the value. Okay, so there's 19 of them out of the first 30. I wanted to double check that very first example. Let's see here. There was an example that had 3 of them that were possible. Down here, this example. So let's put that in our test input. Before and after, and now day 16. Why did I delete the test input? Gee, copying can be hard. Test input and not the real deal. And I didn't get one that matches it. Why is that the case? So we have test input. Okay, and we're reading them. We're pushing them. If examples.length is equal to 30, then we print them. Let's run this on all of them, and let's see console.log examples. This does not look at all like the test input. Wait, did I not grab the right input? Oh yeah, this is right. So this one here should have these 3 opcodes: mul_r, add_i, and set_i. So let's go back to the code. Don't need those. So we have these 3 examples, and supposedly none of them have the same one. So we have all the opcodes. Let result equals opcode if they equal console.log equal. Oh, 2 of them are equal. Why is the 3rd one not equal? So let's figure out which ones are equal and then see which one is missing. So for let I is equal to 0, I is less than opcodes that length I plus plus, const opcode is equal to opcodes of I. Console.log I. So 6 and 9 are equal. 0, 1, 2, 3, 4, 5, 6, 6. So we get bor, which does not seem right. 6, 7, 8, 9, and set_i seems right, but for some reason add_i doesn't work. So let's have a look at add_i. Console log after opcode before. So after we apply the opcode, so we have 3, 2, 1, 1, and we are applying the opcode where we are adding the register A and the value of B. So we are adding register A and the value of B register A, which is a 2. Wait, why? Okay, let's go back to this example. Add I, register 2, which has value 1 in it, plus value 1. Okay, so we're adding register. Okay, I'm counting up the wrong stuff at the end, so never mind. Anyways, no, maybe I'm counting the right thing. So register 2, which has value 1 in it, plus 1 should, okay, what am I adding up here? I'm taking the before of register. My before is a 3241. Console.log before A, B, and C. Before 212. So I'm taking before of 2. Oh, my before has a 3 in it. How did I get a 3 in here? Because the test input doesn't have a 3 in it. Okay, I think the problem is that I'm copying stuff all over the place. So I do want number 0 and number 9. And no, I want number 1, and then multiplication R is 2 and 9. That's the numbers I would like to see. But only the 9 is correct. And I believe the problem is that I would need to copy. So I call equal register on result and after. That's fine. I'm calling opcode on before that. How do I create a copy? Slice. Okay, 129. Yep, those are the right ones. Equal 129. Let's get rid of that. Let's take the real input. So I'm working on the real input. I read the input. I create all those. So let initialize is a function that takes inputs, and I wanted to do all of this. And then it should return the examples. And then let examples equals initialize of inputs. I do not want to list all the examples. Then I do my opcodes. Push all the opcodes. Count as 0. If I messed up the length, something was wrong here. Now for every example, I'm going through, and if the result is equal to the after, then I have a valid opcode for that example. If I have more than 3, then the count goes up. 563. Okay, 563. All right, that wasn't too bad. Let's just format this. Day 16, part 1. Now, I have a feeling that part 2 is going to be super hard because part 1 wasn't that hard. Using the samples you collected, work out the number of each opcode and execute the test program, the second section of your puzzle input. What value is contained in register 0 after executing the test program? Hi Ur, it's going well. I just finished part 1. How are you? What are you up to on this Sunday? Okay, using the samples you collected, work out the number of each opcode. Okay, are the opcodes numbered from 0 to 15 or how are they numbered? Let's have a look at the input here. Yeah, opcodes definitely start at 0. Okay, so opcodes start at 0. Okay, how do we get the number for each opcode now? How do I want to do that? I want to see, so I have this list of opcodes. Valid opcode set push, let ops equal a new map, where is the real code and the index in the list of opcodes. So this is the index, and how do I get my instruction 0? Okay, so I want to set if ops that get the real code, let code equal instruction, it's the first thing. So get the code. If ops doesn't have that, then I want to say ops that set code, comma, an empty list. No, I think I want sets here, right? A new set. And then let possible indices equal to ops that get code, and then possible indices that add the index, and then I'm setting ops that set code possible indices. This is the ugliest way I have ever kept track of a map like this, but better be explicit than make arrows. So if I don't have that code yet, then I set it to a new set. Then I get that set and I add the possible index to it. And then I set code to those possible indices. All right. Now, how do I do that? Once I'm done here, now I need to work on these ops. So I want to do ops get values for real, comma, list, for let real, comma, list of ops dot entries if list dot size is equal to 1, Then we found an opcode, console.log, we found a code. Okay, so one of them only has 1, so now we need to remove that one from all the lists. Okay, so let real ops equal a new map where we have real one and then the index and the opcode. So we found a code. Let index equals list dot values dot next. Is that how this works? Node let s equal a new set s dot add 5 s dot values dot next s dot values dot next no dot next dot value dot next dot value. Can I just do s dot next? No. Okay, so index is the one in here and the real is the real one, so now I do real ops that set real comma index. Okay, we found that one. And now we need to everywhere remove it. Sounds like a recursion problem almost. So we found all those that are unique. So now okay, we found one that is unique. So while true, we have the real ops, and now we need to modify ops.entries. And ops was a list of a real entry and a list of entries. Okay, so we did all that. Now we go through the ops list again. If list that has, if it has the real value, and we're doing this for let identified and index of real offset entries. So if list has the identified one, then we want to list that remove identified, and then we want to say ops that set real the new list. If list that size is equal to this, then we want to ops that delete real. Else we want to ops that set real list. Who is still following this? I'm confusing myself. Okay. So I have a real ops map. So for everything, the real ones have a list. I find the first one that has length 1. And I'm putting it in the real ops set. And then for let identified, comma, index of real ops set entries. The identified code has a certain index. And the index is what's in the list, right? So we identified an index. So I have a real opcode has a list of indices. So here I really need to delete the index. If it has the index, then I want to remove it from that list. Yeah, so we identified a certain index, so now we can delete it from that list. We delete it from all the other lists. If the list is empty now, we delete it, otherwise we make it shorter. And then for all of those, we run this again. Okay, list.values.next, 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 list.remove is delete. Okay, and we're just finding lots of codes. While ops.size is bigger than 0. Okay, now it terminates. So now we have the real ops. Console.log real ops. Okay, so we found where they're all going. And so now that we have this map, we have to read the test input. So we want to read these examples. And then let's have a look at the test input. The test input. This is a lot of input. Is 4 numbers again. So I think what I want to do is I'm just going to copy and paste this into a new file. Oh shit, what did I click? Stop. Oh, I copied and pasted the input in here. All right, that was dumb. So we want input 16 to the txt. That was wrong. I should have just done it in the terminal. Input 16 to the txt. So this is the input here. Okay, and now in day 16, we also want to read the inputs and the program. Let inputs, comma, and the test program, and then res equals await fs.reified input 16 to the txt. Let program equals resulted to a string that split on every line. Okay, I have a program and I have the test ones. Okay. Hello, how's it going? I'm just starting part 2 of the puzzle. Did you solve those already? Moritz and Shinley? Okay. So we have the program here, which is a bunch of lines. So I need to initialize those lines similar to these, where I'm just using this. So for let line of program let registers equal line that match, and I could have a 2 letters, 2 digits for the first one. So I have a register. How does this work when I start? Do I have a test input or something, like an initial state? Because these are the opcodes, right? Let's read this problem again. Shinichi, hey, how's it going? Okay. What execute the test program. What value is contained in register 0 after executing the test program? But what state of registers did I start with? My algebra module with Haskell. Oh, that sounds like fun. Are you doing that just for fun or work, school? Okay. I would guess the last after in first part. Yeah, I was wondering, thanks Finn for saying that. I was wondering if it's 0, 0, 0 or if it's the last one after the first part. But the last one from the first part is probably the right one. Because I have all these samples. Okay. Just for fun. That's a cool fun project. Are you making any progress? Okay, so let's see. Do we have an after here? So we did all this. We have the examples. So let initial state equal examples of examples.length. And then of that one, I want the last one. Console.log initial state. Node day 15. Oh, wrong day. 16. Result to string. Splint is not a function. Splint. It should be a function. That would be a cool function name. Cannot read property 2 of undefined in 224. Because you want examples, we want the last one, not fall over. Okay, 0023 could be the last one. 0023, in fact, is the last one. Okay, so let's just work off the last one. Maybe it should be 000, but we'll figure that out. So we have an initial state, and now for every opcode here, and this, in fact, is not the register, it's the opcode, and then it's input A, input B, and output C. So now we want to say let state equal, like register state is what I mean by state, is the initial state. And now I want to get, so I have an opcode, so now I need the, what did I call it? Real ops is a map from real to index. So real ops that get the opcode, that's my index, and now I do opcodes of that index, and I'm applying it to A, B, C, and I say state is equal to that. And now I want to console log the state. This is a really fun puzzle today. I like this whole idea of writing a compiler, except that I'm failing. Okay, cannot set property 0 of undefined in line 96. Okay. Console.log opcode. My opcode is 12, and now real ops that get the opcode is the index, op, comma index, and then I want to get the index here and apply it to ABC. 12 is index 9, cannot set property 0 of undefined, because I need to call ABC on state. Duh. All right, so now my register Register 0 has value 632, which I believe is what they're asking for. Let's get rid of this one. Console log all the states. So for example, I have 1, 632, 4, 2. Now I would need to know what 1 matches to. All right, and then from this one, maybe it's a multiplication by 1 because I'm multiplying those. That looks good, I think. So back to the input. Oh, yeah, I guess I'm writing an interpreter, but it's only part of the puzzle for Advent of Code. So that is 25 really cute puzzles by Eric Wastel. What am I doing has the link in it. I think, yeah, adventofcode.com. And it's a puzzle every day. They unlock at midnight. So I'm always a few hours late, but I'm doing them just for fun. And so here you can see today's puzzles. And in reality, we're helping the elves to save Christmas, I guess, but we got somehow messed up in time and we're trying to get back to it. So this whole puzzle gave us this interpreter question here, and it's super cutely written. The puzzles are a lot of fun, like this one where you have to write a tiny interpreter, and then it always has test input. So what value is contained in register 0 after executing the test program? So yes, I executed it. Let's see. Oh no, it's too high. Okay, so let's figure out what went wrong. I think I need to debug this a little bit. I did use the last input. I have the opcode. Okay. So let's see what we can do here. Should we try it on a different input? Does it say anywhere what the input is? Yeah, it's super cool and it's really addictive. This is the first year I'm doing it together with some other 60,000 people who are solving puzzles. But they're really a lot of fun. And there's a solution thread on Reddit and some conversations on Twitter. Lots of people share their GitHub repos. Some of us are streaming, so it's really nice. Like Finn is solving them as well. And it's really fun to see how other people are solving them and get some more ideas. Yeah, that's cool. So my number is too high. What did I do wrong? So for that line of program, I'm getting that line, and then I'm getting the index, and then I'm calling opcodes of that index at this, and I'm logging the state. I'm really lacking some unit tests here. Why don't we do 1, 2, 3, this for now? And oh, here's a map. So if we look at the last one here, I was using, oh, I'm only printing the state, so I can't see the opcode. Okay, so let's say, let's print the opcode A, B, and C, and also print console.log. I want to see that real opcode goes to real ops that get the opcode. That's my index. Oh, I should just write index here. And I want to do this just once, so now I want to break, and here I want to do console.log the previous state. So I have a previous state, and then 12.110 goes to a 100. Okay, this seems wrong because I'm just changing the first register. So now I need to look up what 12 is. 15, 14, 13, 12. So 12 is GTRR. So I'm checking if the register values are greater than. So I want to check if register value 1 is greater than register value of 1, which should not be the case. Register value 1 greater than register value 1. Is 0 greater than 0? No. So why am I getting a 1 here? So let's look into this function. log gtrr. Is this even the last one that we're using? Oh no, it's not the last one that we're using. Bummer. So if 12 goes to 9, oh, opcode 12 goes to 9, and I already had figured out what 9 was, but I forgot, of course. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is set I. So I want to set the immediate value. So I want to set how did this work? I'm ignoring B. I want to set the value 1 to the output. Yeah, that seems to have worked. But anyways, I think I just want to try this assuming we started off at 0. In which case it would be 622, whereas before it was 631. Yeah, let's try 622. Oh, that is the right answer. Okay, so my code was fine. The problem was just that I was starting not with 0, 0, 0, but with the last row. Awesome. Oh no, I didn't